I would like to see the sequence, the harmonic sequence spectrum. What I mean is that in the solutions stored here, I have harmonic vectors describing the periodic trajectory of all the variables. Let's say if I'm interested in the harmonic spectrum of this particular variable, I can do this, and then I see indeed the numerical values, which you can also plot with the the plot function. But I would like to know which sequences I have for my three-phase variables. Let's say, what sequences do I have for the alternating current? What sequences do I have for the semi-capacitor voltages, which are defined as states here? I only have the A, B, C versions, but I like to have the 0, positive, and negative sequences. That is something that I can do as a next step. I can go to positive, negative sequences calculations. This is only for three-phase systems. I specify which harmonic domain and time domain sources I would like to work with, those coming from the collocation methods and covering one fundamental period. And then I can say, okay, if I give VG, it will search automatically for these variables. It will add underscore A, underscore B, underscore C, and will calculate the sequences of these three variables. If I give it VD, it will search for VDA, VDB, VDC. It will not work. This is, by the way, something we could try just for learning purposes. If I give IS, it will directly look for ISA, ISB, ISC. So these output variables have to be defined in the equation file, in this file. So they are indeed defined thanks to the clock transformation, even though the states are written as alpha beta variables. Anyways, you can also have something a little bit more elaborate. Sometimes you have three-phase variables, but they have additional letters after. Let's say if I would like to find the references of these ones, well, it's the VC ABC ref. Well, I just have to change it like that. It will look for VC underscore A ref, VC underscore B ref, and VC underscore C ref. This time here, you do not have to include the underscore. It will figure it out by itself. If I do this, naturally it doesn't work because, as I was telling you earlier, it doesn't find VDA, which does not exist. So let me remove it. Let's run this again, and it tells me it has found these three-phase variables and has calculated the 0 sequence, positive sequence, and negative sequence. Likewise for the alternating currents and the common mode voltage reference. The sequence calculations is done. If you look at the list of variables, DSA vars, in the large signal outputs, although in the file I have not defined these positive and negative and 0 sequences as outputs, the toolbox, specifically through this function, includes additional output variables, which are the ones that have just been calculated. This implies that you can also use the plot function to observe their harmonic spectrum and their time domain waveform. Let's start from the time domain waveform, the collocation methods. Naturally, this was for the simple single phase MMC, so I can remove these variables, generate an updated list, which is of course much longer, but it has all the variables that can be displayed in this function. Let's say I would like to see the sequences for the alternating voltage first. So the alternating voltage are defined here. Here they are. Looking at them, I see just indeed three-phase waveforms, and I know, of course, we have B and then A, B, and C. So this is a positive sequence fundamental frequency. If I plot these ones, then indeed the code tells me that the 0 sequence in blue is in fact hidden, it is equal to 0. The positive sequence PS in red is indeed the one of the fundamental frequency, and then the negative sequence is also equal to 0. Let's do this, for instance, with variables that have more harmonic content. Let's say if I go to main and I would like to check the some capacitor voltages, what I have to do, I have to look for VC, maybe VCR as well. I run this. I have now calculated the positive, negative, and 0 sequences for the sum capacitor voltages. I go to the plot function, Control D, here they are. Well, I have to update again the list, but I don't have to update everything. Let's copy just this. And let's have a look at the ABC waveforms first for the sum capacitor voltages of the upper arm. Here's what they look like. If I want to know about sequences, I can have a look at this. And I see this time that the 0 sequence is equal to that. It is a 0 sequence with essentially a constant component plus a ripple. The positive sequence is given in red. It is essentially a fundamental frequency waveform, while the negative sequence in yellow has mostly a 100 Hz component. So this is something perhaps not so easy to see at first sight, but okay. I can also check their harmonic spectrum directly. So indeed, for the 0 sequence, it is mostly a constant component plus some small ripple at 150 Hz. For the positive sequence of this upper arm sum capacitor voltage, it is mostly a fundamental frequency, so 50 Hz component, plus some component at 200 Hz. And lastly, for the negative sequence of the upper arm sum capacitor voltage, it is essentially a 100 Hz component with some 250 component, quite small.